Hello and welcome to an episode of Chemistry Explained. For today's video, we'll be looking at the groups otherwise known as families on the periodic table, and one in particular, the noble gas family. This episode will be covering what the noble gas family is made up of, what their role on the periodic table is, trends in the noble gas group, and a comparison to another periodic table. Well, all of that is to come. Now, moving on to our next topic, the noble gas family. This group, known as the noble gases, are elements that occupy group 18 on the periodic table. This includes helium, neon, argon, krypton, xenon, and radon. All these elements are non-reactive elements and are found everywhere in today's world. For example, neon is used for advertising signs, argon is used in light bulbs, and xenon is used for headlights for new cars. Well, what is similar between these elements, you wonder? Well, it's quite simple, really. All gases are highly stable to having the maximum number of valence electrons in their outer shell, which means they are very unlikely to react to anything. Other characteristics this group has is that they are very good at conducting electricity. They are also odorless and colourless. Now moving on to our next segment, and that is the trends in the physical properties of the noble gases. As stated by the Libratex group, periodic trends are specific patterns that are present in the periodic table that illustrate different aspects of a certain element, including its size and its electronic properties. For example, one periodic trend may include its electronic activity, ionization energy, electron affinity, and its atomic radii. Normal gases are monoatomic and chemically inert under normal conditions, and hence are also named as inert gases. These gases are present in small quantities in the atmosphere, and so they are also called rare gases. As you can see on the graph above, you can see all the elements in the noble gases boiling point, just one of the group's periodic trends that this group shares. Moving on now, we'll be answering the following question: why are the noble gases positioned on the periodic table the way they are? Along the extreme right-hand column of the periodic table of elements is a group known as the noble gases. Scientists believe them incapable of reacting with any other element on the periodic table, hence why they are on the far side of the periodic table opposite to alkali metals, where their reactivity is much higher with other elements on the periodic table. To move on from this topic, we'll be looking at the element xenon and its function and role within the noble gas group. Xenon is rare and exists as a trace gas in the Earth's atmosphere to the extent of about 1 part in 20 million. The element is also found in gases emitted from some mineral springs. Xenon is only commercially obtained by industrial liquid air plants that can extract the gas. One of xenon's most important properties is its inertness. The reason xenon doesn't react easily is that it's so stable on its own. This stability is caused by its full set of valence electrons. These are the electrons farthest from the atom's nucleus, and are the only electrons that participate in chemical bonding. When an atom does not have a full set of valence electrons, it will bind to another atom in order to complete its set. Thus, xenon's full set of valence electrons allows it to exist comfortably on its own. Next, we move on to the atomic structure of the noble gas atoms. Like atoms in most groups on the periodic table, elements increase steadily in atomic radius from one period to the next due to the increasing number of electrons. The size of the atom is related to several properties. For example, the ionization potential decreases with an increasing radius because the valence electrons in the larger noble gases are further away from the nucleus, and are therefore not held as tightly together by the atom. Noble gases have the largest ionization potential among the elements in each period, which reflects the stability of their electron configuration and is related to the relative lack of chemical reactivity. Moving on to the final segment of this episode is the comparison to another periodic group. We'll be comparing the similarities and differences between the noble gas group and the halogen group. The halogen group includes the following elements: fluorine, chlorine, bromine, astatine, and iodine. Halogens have only 7 valence electrons compared to the noble gases with a total of 8. Some similar characteristics involved with these elements is that they can form compounds with almost all other elements on the periodic table. They are highly toxic in their raw state, and they vary in different states of matter, solid, liquid, and gas form. In conclusion, halogens and the noble gases are very distinct from the other elements on the periodic table, as seen in their properties and their reaction with other elements. Thank you for watching, and we hope you enjoyed.